Welcome to the UAV Outback Challenge Deliverable 2 pre-flight checklist segment for Team Altostratus. This will give us a bit of a rundown on what we do to prepare the aircraft before we do any flight testing. We run through a printed hard copy of this checklist. We retain all of those for future reference and to build our database and collect as much evidence we can of testing in different weather conditions. We always pre-record a few details just to start off with date. Flight location, we always fly to an MAAA field. We're based out at Mount Cottrell. Pilot, who's going to be piloting the manual component of the flight. Takeoff time, landing time, we can work out durations and backtrack fuel burns. Mass distribution, we'll cover that later in the checklist. Landing mass, and then subsequently the mass delta. Environmental conditions, wind speed, takeoff voltages and landing voltages, again to work out load and power draws, and as well as just general comments on aircraft condition at landing. So that's the intro, and we'll kick off into the rest of the parts.
Alright, step 1.1, fuselage. Ensure no play in front landing gear assembly.
Front landing gear is rigid.
Check. 1.2, ensure front wheel spins freely.
Spin freely, axle's not bent.
Check. 1.3, ensure no play in rear landing gear assembly.
Landing legs are tight.
The check note also says ensure that the four mounting fasteners are correctly torqued. Have we adjusted since last tightening?
No, they're still fine. They're marked as well.
Check, check, yep. 1.4, ensure the rear wheel spins freely and the axles are secure in the frame.
Check and check.
Good, good. 1.5, ensure engine mounting is rigid. Check the four rubber mounts.
ISO mounts are tight. Bulkhead's tight. Check.
Check. 1.6, ensure engine bulkhead is rigid. Check that 7 fasteners are tight.
Bulkhead's tight. All fasteners are home.
Check that. 1.7, ensure payload mechanism is rigid. Check the servo linkages for play.
Assembly's tight. No loose fasteners.
The note says ensure servo lever arm screw is tight.
Yep. Lever arm's tight.
Check.
Yep.
1.8, inspect GFRT fuselage for damage.
Fuselage is in good condition.
Alright, now on to section 2, powertrain, static inspection. 2.1, inspect propeller for damage, remove the cover first. Thank you.
Propeller in good condition.
Check that. 2.2, inspect engine for damage and shaft play.
No shaft play. Spark plug left at home. Engine looks good.
2.3, ensure fuel tank is secure. The note says, check fuel tank strap for wear and ensure tension.
Straps tight, tank is secure.
Check fuel tank to fuselage fasteners.
All fasteners marked, all fasteners home, check.
2.4, inspect fuel lines for leaks. The image note says, inspect fuel lines for wear and leaks, check around joints in particular.
Yeah, all fuel lines onto barbs, all fuel lines with clamps fitted, no leaks. Fuel filter tight.
Check that?
Yep, check.
Excellent. 2.5, ensure sufficient fuel for flight schedule. Approximately 1 litre per hour of flight at 85 kilometres an hour at 100 metres.
Yeah, more than sufficient.
Check that. Ensure 2.6, ensure CDI unit is secured.
CDI unit secure in airframe. Yep.
2.7, ensure throttle servo is rigidly mounted.
Throttle servo secure, no play. Throttle linkage secure.
2.8, inspect all CDI unit wiring looms and throttle servo wiring looms. Look for abrasion and damage to looms.
Looms are in good condition and are routed correctly to airframe.
Check that.
Check, yep.
All right, now we're on to section 3.0, assembly procedure. 3.1, mount center section of main wing carefully, feed loom through fuselage. Do you need a wrench?
Yeah, I think it's the next step.
Ah, yes. All right. Loom is fed through fuselage.
Check.
3.2, install 2 main wing fastener assemblies and torque to 10 Newton meters with the 5mm hex drive.
Both fasteners torqued, check.
3.3. Inspect boom to centre wing fasteners. Check paint pipe. Check paint marks for movement. 2 fasteners to inspect.
Paint mark hasn't moved, fasteners still tight. Paint mark hasn't moved, fasteners still tight. Check both of those.
Check that. 3.4. Install main wing spar. The image note specifies that the wing spar should be equally spaced in the main wing section.
Spar installed, check.
Check that. 3.5. Mount left and right hand side wing sections onto spar. Now do you need a hand for this?
Should be right. Let's be there. Check.
3.6. Feed aileron looms through centre wing section into fuselage.
Left loom fed through. Right loom fed through, check.
Check that. 3.7. Seat left and right hand side wing main sections onto centre wing section.
Wing seated.
Check that. 3.8. Tighten M5 nylock nuts on the underside of each main wing section. Torque each nut to 8 Newton meters.
confirm both us and stocked.
Check that. 3.9. When M5 nylocks are torqued to 8 Newton meters, fit covers and remove the flight tags.
Covers fitted, tags removed.
2 tags, check that. 3.10. Mount left and right hand side boom and rudder assemblies. Be sure to make electrical connection. Ensure the servo covers are located towards the center plane line. All the planes,
Left hand boom, electrical connection. Connect to home, gate closed. Right hand side boom, electrical connection. Connect to home, gate closed.
So that is ensure servo covers are towards plane center.
Correct.
Check on that.
Check.
And electrical connection made.
Check.
All right. And .311. Tighten boom to boom fasteners. Ensure correct orientation of concave washers.
side fastener torque. Left-hand side fastener torque.
Check that. As an added note, should I write down the tightening strength used?
Yeah, 4 newton-meters, both those.
3.12, 3.12, boom to rudder fastness check. Check the movement on paint mark.
Mark hasn't moved on left boom, check. Marks haven't moved on right-hand side boom check.
Check that. 3.13, mount elevator section onto rudders and make electrical connection. Be sure to install retention feature onto electrical connectors. Do you want to handle this one?
See how I go.
All right.
Left-hand side connection made. Retention feature attached. Right-hand side electrical connection made. Retention feature attached.
Check that. 3.14, tighten elevator to rudder fasteners. 4 fasteners requiring tightening.
all fasteners torqued.
Shall I record Tyson?
3 Newton meters.
Check that. 3.15. Route servo leads through abrasion sleeve and secure to fuselage.
Abrasion tube onto servo looms. Fuselage mounting points. Servo leads mounted.
Right, 315 route servo leads through abrasion sleeve and secure to fuselage. Check. 316 install wing cover.
Wing cover installed and torqued.
Check.
Check.
And that completes the build section, I believe. All right, next section is 4.0, wing inspection. 4.1, inspect main wing leading edge for damage.
Main wing leading edge looks good, no damage.
Check. 4.2, inspect main wing overall condition.
Main wing is in good condition.
Check that. 4.3, inspect rudder leading edges for damage.
No damage to rudder leading edges.
Check that. 4.4, inspect general condition of rudders.
Rudders are in good condition.
Check that. 4.5, inspect leading edge of elevator.
Elevator leading edge in good condition.
Check that. 4.6, inspect general condition of elevator.
General condition good. Foster report.
Confirm that. Section 5.0, control surface activation. 5.1, left aileron control linkage does not have excessive play.
Left aileron control linkage is good.
Check that. 5.2, right aileron control linkage does not have excessive play.
Right aileron control linkage is good.
Check that. 5.3, left elevator control linkage does not have excessive play.
Left elevator control linkage is good.
5.4, right elevator control linkage does not have excessive play.
Right elevator control linkage is good.
Confirm that. 5.5, left rudder control linkage does not have excessive play.
Left rudder control linkage is good.
5.6, right rudder control linkage does not have excessive play.
Right rudder control linkage is good.
Check that. We are now on to Section 6, electrical supply. Battery voltage at APM is equal to 5.2 volt or greater.
.2 sufficient.
6.2, CDI battery pack voltage greater than 5.2 volt.
5.2 sufficient.
6.3, servo battery pack voltage greater than 6.3 volt.
Servo pack 6.3 sufficient.
All recorded and confirmed. Section 7, avionics. 7.1, ensure pitot tube is unobstructed, remove tag.
Pressure lines are not obstructed. Sensor is in good condition. Check.
7.2, ensure pitot tube lines are unobstructed.
Yep, check.
Confirm that. 7.3, ensure avionics module fasteners are tight.
Check.
7.4, ensure all looms are undamaged and retained correctly.
Confirm all connectors are home, all routing is correct.
And all looms are undamaged.
Check, yes, looms are in good condition.
7.5, ensure connectors are home. And you just check that.
Yeah.
7.6, confirm GPS lock.
LED indicates GPS lock.
Check. Section 8.0, communication links. 8.1, 2.4 gigahertz signal strength range test using the range test function on transmitter.
Setting transmitter to range check function. Work away 30 meters, ensure surfaces still move.
Surfaces are moving, confirmed.
Eight 4 gig link check.
8.2, ensure 2.4 gigahertz transmitter is above 60% battery prior to takeoff.
Check, battery health 85%.
Confirm that. Check presence of 8.3, check presence of 5.8 gigahertz signal link.
5.8 link is up and signal strength is good, check.
8.4, verify presence of 900 megahertz signal link.
900 meg link is up and health is good, check.
Alright, that ends section 8 communication links. Next is section 9, payload release. 9.1. Do we want to go straight in? Alright. 9.1, check for unimpeded actuation of mechanism.
Payload mechanism is working well.
9.2, ensure all mounting hardware is torqued correctly.
Fasteners are torqued, check.
And can I record torque value?
Yeah, 3 newton meters.
9.3, ensure parachute is packed correctly.
Check, parachute's packed, payload's mounted.
9.4, ensure payload is latched correctly and the pin's fully home.
Pins are engaged, payload is secure.
Solid. Check that. 9.5, ensure water bottle has at least 500 ml of water.
Check, water bottle's full.
Check. Section 10, servo function. Turn on receiver.
Check.
10.2, turn on 2.4 gigahertz transmitter.
Check.
10.3, front servo gear, front landing gear servo, mounting sweep and center point check.
Front landing gear steering actuation, check.
10.4, left aileron, mounting sweep and center point check.
Center points are good, sweeps are good on both low and medium.
Check that. Right aileron, mounting sweep and center point check. Step 10.5.
Right aileron, check.
10.6, elevator, mounting sweep and center point check.
Sweep and center point, check.
10.7, left rudder, mounting sweep and center point check.
Left rudder, check.
10.8, right rudder, mounting sweep and center point check.
Right rudder, check.
10.9, drop mechanism function.
Payload releases correctly, check.
All right, we will skip step 11 at the moment, which is flight configuration, as there is no desired flight plan at this moment. Step 11 is flight configuration. 11.1 is ensure waypoints match the desired flight plan, and we'll mark that as not applicable. Step 12, environment. 12.1, Bureau of Meteorology has been checked for weather warnings. Verify there are no weather warnings. Check. 12.2, airspace is suitable for flight plan. And that's not appropriate, not applicable for today. 12.3, airspace is suitable for UAS flight. Not applicable for today. 12.4, base station wind speed recorded. And I will verify front page. Wind speed has been recorded as 0 and is still at 0. Check. 12.5, base station wind gusts recorded. Wind gusts have been recorded. 12.6, base station wind direction recorded. Check, wind direction is northerly. 12.7, ambient temperature recorded. Temperature has been recorded as 15.8. Check. That's the end of section 12. Section 13, mass distribution and centre of gravity measurements. 13.1, fit cover and zero scales.
Installed, scales are zeroed.
Check that.
Check.
13.2, measure weight of UAS system.
UAS is on the scales.
Check. 13.3, record and calculate the mass distribution of the UAS.
Front wheel weight is 3.85. Left rear is 8.65. Right rear is 8.2. Brings us a total mass of 20.7 with a front percentage of 18.6, which is within our target percentage of 20% plus or minus 2%. Centre of gravity check.
Alright, I've recorded that. Weight, mass distribution. Check. End of stage 13. Go. Section 14, Powertrain Dynamic Test. 14.1, ensure CDI unit is active. Check for illuminated CDI power LED.
CDI power LED is on.
Check. 14.2, ensure engine choke is on.
Engine is choked.
14.3, ensure aircraft is secure and has no ability to move.
Check.
Check. 14.4, make it known to bystanders that the engine will be fired.
Engine will fire. Caution.
Check. 14.5, spin the motor until it fires.
Check.
Step 14.6, remove choke.
Choke off. Check.
Step 14.7, spin the motor and fire the engine. Stand by.
Engine running well. Check.
That's 14.7, check. And optional 14.8, let engine run for 2 minutes at varying throttle levels to ensure running. Not applicable for today.